Hello everyone, we are Team NDSU and we are proud to show you our submission for the 3M Disruptive Design Challenge, the Dazzle Box. Imagine a scenario where medical aid is needed in a remote jungle location. The supplies must be airdropped to a designated location, but during descent, the parachute of the package fails. Our challenge was to design an airdrop container that would not only survive the fall, but protect the contents inside. When discussing possible designs for our submission, it was important to keep in mind the most important aspect of the project, the impact. Conventional square-shaped containers allow high stress concentrations to occur, resulting in more than likely a broken box and ruined supplies. Our original design was intended to be as spherical as possible without being too complex to manufacture. Our first idea was to make the container into a truncated icosahedron, similar to the geometry of a soccer ball. Unfortunately, the shape was not as easily transportable due to its geometry. This is why we decided to construct our box into a shape called a truncated octahedron, one of only 5 convex polyhedra with regular faces that fill space, meaning the shape can be perfectly stacked together for easy transportation. This shape not only prevents against high stress concentrations upon impact, but it's also an easy shape to manufacture, consisting of faces of hexagons and squares with identical side lengths. Our design for this project consists of 3 main components. A semi-flexible polycarbonate shell intended to absorb impact by flexing slightly upon hitting the ground, a gradient foam system that gradually decelerates the payload and diminishes forces sustained to the fragile components inside, and an efficient, easily accessed payload that is easy to transport after the materials have safely reached the ground. The polycarbonate shell material was chosen for its high toughness and its ability to absorb a lot of energy before fracturing. Polycarbonate is also a widely available commercial material that is relatively inexpensive and easy to work with. Another challenge we faced was how to attach the pieces of polycarbonate together. A possible solution could have been to use mechanical fasteners such as nuts, bolts, and screws. However, these fasteners do not allow for flexibility upon impact, which would make the box susceptible to major stress concentrations. Our solution was to use a variety of tapes provided by 3M to create a tape composite that allowed for a strong bond between the 2 pieces of polycarbonate, but also allowed for flexibility when the box impacts the ground. The tape composite we came up with consists of 3M 300 low surface energy double-sided tape to improve adhesion to the container, 3M fiber reinforced tape strips perpendicular to the seams of the container to resist bending force upon impact, 3M vinyl tape which adds flexibility and helps with elongation of the seam during impact, 3M fiber reinforced tape strips at 45-degree angles with respect to the seams of the container which resist bending and shear force upon impact, 3M vinyl tape which adds flexibility and helps with elongation of the seam during impact, and finally, 3M aluminum foil tape, which adds rigidity and durability on the exterior of the tape composite. The edges of the polycarbonate were also lined with 3M marine adhesive sealant to aid in waterproofing of the container. In emergency situations, the application of this sealant could be eliminated to expedite the manufacturing process, since the tape composite seams are designed to be watertight as well. Upon impact, our container will sustain an estimated 8,890 joules of energy. In order to protect the contents inside the box, that energy must be greatly dissipated. To do so, we used a gradient foam system that was inspired by NASCAR's safer barriers, which also use a gradual foam system to diminish impact forces on high-velocity collisions. The foam system gradually decelerates the payload and diminishes forces sustained to the fragile components inside. Our foam system consists of cross-linked polyethylene foam on the outside of the container, lining the outer edges intended to take the initial impact and diminish as much energy as possible, followed by high-density polyurethane foam, lining the inside of the container to finish slowing the payload as it comes to rest after impact. Finally, viscoelastic polyurethane foam, more commonly known as memory foam, used to line both the inner and outer layers of the payload. This foam was chosen to begin the deceleration of the payload as well as the deceleration of the glass bottles inside the payload. The payload of our container was designed to not only effectively and securely store the required supplies inside, but it also acts as a way to easily transport those supplies once they hit the ground. The exterior of our container is covered in a colorful and distinct geometric design inspired by Dazzle camouflage. Dazzle camouflage was a surface decoration technique developed by the British Royal Navy as a way to obscure the heading of their naval vessels at sea. This surface decoration has the opposite effect of traditional camouflage, which makes our container stand out in any natural environment due to its harsh geometrical designs and vastly contrasting colors. The exterior of the container also has flashing lights that make the container visible in poorly lit environments. One of our main concerns while designing this container was the ease of manufacturability. Many of the components used to construct our box were made to be easily manufactured as well as modular, so each of the components can be added and replaced as needed. In order to save time while applying the tape to our box, we prefabricated the tape composite into strips which were then quickly and easily applied to the container. In future scenarios, this tape composite could also be prefabricated, allowing for quick and easy packing and unpacking of materials in emergency situations where time may be tight. While testing, one prefabricated strip of our tape composite was able to be applied in under 30 seconds. This would allow someone to pack and seal the constructed container in under 10 minutes. The Dazzle camouflage on the outside of the container could also be prefabricated to be easily added to the container. Upon impact, many of the components of our box can be reused in ways that aid in emergency relief. The outer shell of our container can be deconstructed into a light beacon to signal additional emergency service personnel if necessary, or be used as a light source for emergency situations where light is not available. The foam lining inside of the container and payload can be removed and reused to construct sleeping mats, pillows, or seating cushions. The payload of our container has straps that turn the payload into a functioning backpack intended to easily relocate the supplies in the container if needed. The payload of the container is also waterproof and could be used as a water storage device as well. The total retail cost of our prototype before taxes was $602.28, excluding the 3M materials used to construct the box. It is assumed, however, that if this container was to be mass manufactured, the cost of the box could be greatly reduced. The entire experience of the 3M Disruptive Design Challenge has been fantastic from start to finish. Our entire team has been exposed to the great benefits of 3M industrial tapes and adhesives. This expanded knowledge has opened the opportunity for us to use industrial tapes and adhesives in place of mechanical fasteners in future projects as engineers. Team NDSU extends a thank you to all of the amazing staff of North Dakota State University, 3M, and Ketchum. And a special thank you to Dr. Kalk Vang, Dr. Ali Amiri, Dr. Chad Ulvin, and Dr. Jordi Esteva Deordal.